5-2. We're talking about trig ratios today. So we're actually getting into now the idea about trigonometric or trig functions and what kinds of applications that they might have. So this is kind of the beginning of all of that process. So 5-1, we dealt with angle measurements and how we can write them. So now we'll be ready to use those angles when we have them as part of a triangle. So today we're going to look at just what are the trig ratios, what does that mean, and being able to write them and kind of type them in on our calculator. So that's our plan for today. So let's start with the first part of this, a trigonometric function. Sounds like a really complicated name. Trigonometric just comes from the prefix tri like triangle meaning three. Functions you guys are familiar with. So function is something that we are. All right, so function, definition. For every x, there's exactly one y. We talked about those in the beginning of the year. So all of these are functions. They have that for every input, there's exactly one output. So we know that they behave like that. All it really means, though, is it's a function whose rule, the equation, is given by a trig ratio. So in the equation, there has to be a trig ratio, and we'll talk about what those trig ratios are. So just like a radical equation has to have a radical in it, a trig or trigonometric function has to have a trig ratio in it. So anything that has that in it is considered a trigonometric function. So what are these trig ratios? This is the important piece of this now. So a trigonometric ratio. First thing to think about is what is a ratio? Well, ratio is just a fraction. It's a comparison of two things. So a trigonometric or tri, that means it's a ratio in a triangle. So coming from that word triangle, so it's ratios in triangles, comparison. So when we think about those words, it helps us kind of figure out what we're talking about. So it's a comparison or a ratio of two sides in a right triangle. It's got to be a right triangle. So that's an important piece of this. So comparison of two sides in a right triangle. The biggest thing to keep in mind then in a right triangle is you have to know which angle that you are using. So the values of these trig ratios depend on, and I circled this little symbol. Remember what that little symbol means again? That's theta. That's kind of our universal go-to symbol for an angle measurement, one of those acute angles in the triangle. So it matters which angle you use when you write those trig ratios. So they depend on an angle. So that's a really big idea of trig ratios. All right, so let's go through and talk a little bit about these different functions. So the trigonometric ratios come from all of the different pieces in a right triangle. So I want to go through this first one here, and we're going to talk a little bit about the picture before I get into the actual names of the ratios. All right, so let's take a look at the picture. I'm going to have you circle or star or something, find your theta. Be like all those little bad jokes. Find theta. Here it is, right? Okay, so there's your theta. What we want to talk about is what are the three parts in this triangle as related to theta, depending on theta. Hypotenuse, if you look at where the hypotenuse is here, I'm going to make it a little darker. The hypotenuse is always the side that's across from the 90-degree angle. No exceptions, hypotenuse. And that makes it, because it's across from the 90-degree angle, always the longest leg in the triangle. And think about that, why that's reasonable. If it's across from the 90-degree angle, it has to be the biggest then, right? Because in a triangle, the three angles add up to 180. So if that one's 90, the other two together have to be 90. So hypotenuse is the longest. All right, now let's talk about the opposite and adjacent. So for theta over here, the side opposite is all the way across the triangle, not connected to it at all the way across. Think about sitting at the dinner table. So if you're around a rectangular table, something like that, and if I say you're sitting opposite someone at the table, that means you're across the table from them. So they're always on the other side of the table. So that's the same thing as when we think of side opposite. If it's opposite the angle, it's like across from the table at the dinner table. Adjacent. The adjacent side is the one on the bottom there in my picture. Think about if someone's sitting at the dinner table adjacent to you. That means they're sitting right next to you. So think about that for the angle. It's right next to you in the angle. In other words, it's the side that makes up one part of that angle. So adjacent and opposite are super important when we talk about what's happening with these different values as we look at them. So those are the big things to keep straight here. All right, so let's go ahead and talk about the different ratios in this triangle then. So the trigonometric functions for this. So for the first part, when we look through these, I want to give you the name of the function. So the first big trig ratio or trig function that we have is called the sine function. The abbreviation is SIN, but we say sine when we read that, and you can never leave it how I just wrote it. There always has to be an angle measurement after it. It's always sine of an angle. It has to be of something. It has to be dependent on the angle that you're being given there. So it's really important that you realize that it's sine of the angle. You can't just say sine because it's dependent on which angle it is. Okay, so the ratio for sine, if you think back to geometry, see if you can remember what sine, think of your little SOHCAHTOA, if that helps you. Some people remember that and talk about that. We'll do a lot of that over the next few days. So sine is the side opposite over the side that's the hypotenuse. So opposite over hypotenuse, that ratio of those two numbers is the equal to the sine of the angle. All right, so next one, cosine. So the cosine function. So think about what the word prefix co means, like coterminal. They share something. They have something in common. There's some relationship between them. Co-functions are the same kind of situation. So sine and cosine are related to each other. That's why they're named that way. We'll talk more about how they're related when we get to their graphs. This one's abbreviated COS, and again, of the angle, could never just stop with COS. So when I read that, though, when I say this, I say cosine of theta. So we don't really have to abbreviate the name when you say it. It's just easier when you write. Okay, so which ratio in the triangle is cosine? Well, in SOHCAHTOA, that is adjacent. All right, so the ratio for cosine then in SOHCAHTOA here is adjacent over hypotenuse. So again, it really depends on which angle you're using, so it's important that you know which is adjacent and which is hypotenuse for that angle that's theta. All right, and the third one is called tangent. So the name of the function is tangent. That's abbreviated TAN of theta, so tangent of theta when you say that. And the ratio for that one is opposite over adjacent. So we've defined these ratios so we're able to work backwards and solve what we need to. The ratios in those triangles are equal to those trig functions. Okay, now there are, for every one of these functions, what we call a reciprocal function. So I want you to think about what the word reciprocal means. So reciprocals are where you take a fraction and do 1 over, or you flip. So if you have 2 over 3, the reciprocal would be 3 over 2. Every one of the trig functions has a reciprocal function. So I want to go through what those would be. So for our big 3, it would mean 1 over sine, 1 over cosine, 1 over tangent. So the reciprocals meaning flip them. They have names. So the reciprocal for sine is called cosecant. That's the name of it. The reciprocal for cosine is called secant. Again, that co-function idea, they're related. And then the reciprocal for tangent is called cotangent. So it means 1 over, 1 divided by. So their abbreviations are CSC of theta, SEC of theta, and then COT, cotangent. And again, when I read those, I would say cosecant, secant, cotangent. Say the whole word so people know what function you're talking about. But again, always has to be of the angle. I need to know that I'm always using that angle to do that. How do you get their definition? Well, just take the ratios you had from the original and just flip them. So sine was opposite over hypotenuse. So that means this one's going to be hypotenuse over opposite. Cosine was adjacent over hypotenuse. That means we're going to be hypotenuse over adjacent. And then the last one, tangent and cotangent. Tangent is opposite over adjacent, so that means we're going to have adjacent over opposite. So these reciprocal functions sometimes are used just when things are easier to solve for, like maybe you want the variable in the numerator instead of the denominator, or the behavior that a particular graph takes on looks more like that sort of function. We'll look at the pictures in Chapter 6, the graphs. But they're just a reciprocal. That's just that flip. Now, when you look at your graphing calculator, the signs, cosine, tangent buttons are those big 3. The secant, cosecant, cotangent are not buttons on your calculator, and they're not what's right above. So when you look at like this inverse sine, and inverse cosine, inverse tangent, those are not the functions we're talking about. Those are the opposite operations, just like when you look at the squaring key, square roots above it. That's different. Inverse is not the same thing as reciprocal, so we can't use that when we're looking at our graphing calculator. So we'll talk about that in a little bit when we do some calculations. All right, so let's get into some actual problems, some examples of things that you can do if you know the relationship in the triangle. So it says find the values of sine, cosine, and tangent for angle L. Okay, so let's talk about how we label triangles for a second. Angle L is this guy right here. So we use capital letters to stand for angle measurements. So angle M is the right angle P is that other acute angle on the top. When I label the side lengths, I use the lowercase letter for the letter that's across from that side. So for example, if this is angle L, across the triangle is going to be side L. So little l would be 9. If this is angle M, across the triangle would be little m then. So little m is 24. That means across the triangle from angle P would be little p, which happens to be the one I don't know. So I don't know what that number is. I'm going to have to figure that out. So I have a missing side in my little triangle here. So just kind of a convention thing. So capital letters for angles, lowercase letters for sides are always across from the angle that you're given. All right, if they want you to find sine, cosine, and tangent for angle L, I need to have all three sides of the triangle to be able to do that. I need all three to do the ratios. So I am missing a side in a right triangle. How do you find a missing side in a right triangle? Well, if you're thinking back to geometry, hopefully you're coming up with this. The Pythagorean theorem is a way to find the third side in a right triangle, and normally I think most people would say this. Now, if you look at your picture, though, you don't have an A, B, and a C, right? That's not what the letters are that we use. What is the side C always in the Pythagorean theorem? Well, that's the hypotenuse, and the A and the B are the two legs of the triangle. So it doesn't matter which one you call which. So for our situation, we have the hypotenuse. We know what's across from that right angle. We're missing a leg. So when I go through to solve this, I'm going to solve for that P squared, and it's going to be one of the legs, so either the A or the B when you write that. All right, so let's go ahead and solve for that. So we'd have P squared plus 9 squared equals 24 squared. And I'm going to go ahead and solve for P. So square each of these. So I square the 24, and I believe, let's see, what was that? Was that 576? I think. And then subtract the 81, and you get 495. And then square root. Now, normally it's a really big deal to say, okay, when you square root, you get two answers, plus or minus, all that good stuff. Well, in this situation, does it make sense to think plus or minus? It's a triangle drawn with just a two-dimensional figure. Could you have a negative length? No, that doesn't make sense. So this side, we don't need to have plus or minus, but what we do need to do is simplify that radical. So is 495 a perfect square? Well, no, it's not. So check it, but it's not. See if you can find a perfect square that divides into 495 evenly. So the biggest perfect square and what's left over. So pause the video, see if you can simplify it. All right, so I got 9 and 55, so that would be 3 times the square root of 55. So this side P is 3 times the square root of 55. All right, now, just to make this easier for me, I'm going to, again, go back to this angle L, and I'm going to do some labeling. What side is opposite the triangle from angle L? All the way across. So think like sitting at the dinner table, all the way across, the 9 would be the opposite. Okay, what side is adjacent to angle L? Sitting right next to it. Well, that's the 3 square root of 55. That's the adjacent. Hypotenuse is always across from the right angle. Just taking a moment to do that might save you a little bit of time when you actually write these values then. All right, so we're going to go ahead and write the ratios. So sine for angle L, that means we write sine, that's the function. L is what angle we're using to write the ratio, and sine is opposite over hypotenuse. So in this triangle, opposite is 9, hypotenuse is 24. So can you reduce? Sure, that would be 3/8. Always reduce, always rationalize. Write your answer in the easiest form you possibly can. All right, cosine, angle L is adjacent over hypotenuse. So in this triangle, go ahead and peek. Adjacent would be 3 square root of 55. Hypotenuse is 24. Can you reduce? Sure, the 3 and the 24. So that would be square root of 55 over 8. All right, last one of the big three here. Tangent of angle L is opposite over adjacent. So opposite is 9. Adjacent is 3 square root of 55. That number's not so nice. But let's see if we can reduce it first. The 9 and the 3 will reduce. So that would be 3 over square root of 55. Now, normally we don't like to leave our answers that way to have that radical in the bottom. They're really hard to work with. So we want to rationalize these. So you don't have to show what I'm going to show next. You can just do this in your head. But we multiply by that radical. If you multiply radical by itself, we can rationalize or get that whole number, and then we'd have 3 square root of 55. So you can go ahead and go right to that answer, but always reduce and always rationalize. Now, those are the big three. We could find the reciprocals if we needed to. How would this question change if you would use angle P instead? If I had said, nope, I want you to do angle P. Well, the opposite and the adjacent then would have flip-flopped. So we would have been back to then cosine and sine switching. So it's really important that you realize, oh yeah, okay, if I use a different angle, opposite and adjacent will flip. So I'm going to have a different setup. I'm going to have a different situation of how I write those out. Okay, speaking of how we write things out, let's take a look at a couple examples where they're giving you the values for a particular function. So when I look at this function, it's giving me what cosine is, cosine of theta. Now, if I know cosine ratio is 2 over 9, think about what you know about that triangle. If you know cosine is 2/9, that means you know the adjacent side and you know the hypotenuse. At least a reduced form of them, you know what that ratio is. So what I'd like you to do is draw yourself a right triangle, put in a theta somewhere for one of the acute ones. I'm just going to put it down there. And let's put in the numbers we know. The side adjacent is this one, so that would have to be 2, and the hypotenuse is 9. I really want you to get used to thinking about what the picture would look like. Now, could you find this side of the triangle over here, that third side? Sure, Pythagorean theorem, right? So if we needed it, we could find it. If you could find that third side, you could find any trig ratio because you have all three sides of the triangle. So knowing a trig ratio is so important because you know the triangle that it's giving you two sides, that comparison, you can find the third. Okay, now what are they asking you for specifically? They want you to figure out what secant of theta is. So look back at your table. Which one is secant or reciprocal for? Well, that's a reciprocal for cosine, meaning if we already had cosine, to find secant, then all we have to do is a reciprocal. So did we really need the triangle to do secant to know it was hypotenuse over adjacent? No, not really. But what if I'd asked you for tangent instead? Well, then I absolutely would need the triangle. So I need you to realize that these numbers are making a triangle. That's what it is. And we can find any trig ratio from them then. So when we look through and do those values. So secant would be 9 over 2. Okay, next one. Sine of theta equals that. Okay, now this is a little bit trickier. Remember we said these ratios should be ratios of two sides in a triangle. That doesn't look like a ratio to me. It's a decimal. But is there a way that we can make it a ratio? Can you change decimals into fractions? Sure. Let's just write what that would be equal to. Some people just do it on their calculator. I'm just going to write what it means. 525 over 1,000, right? We can reduce that. So go ahead, reduce that. I think that's 21/40ths. I can actually make a triangle then that represents that situation. So I'm just going to pick my theta to be down here. Sine is opposite over hypotenuse. So the side that's opposite theta would be over here. The hypotenuse is there. Could I find this side of the triangle, the third one? Sure, I could use Pythagorean theorem, depending on what they wanted me to find. So if they even give you a decimal, and let's be realistic, a lot of times we'd rather work with decimals when we're typing stuff in than fractions, right? It might be faster. If they give you a decimal, you can still find out what ratio that would be. Just put it as a fraction, and then we have that triangle. Okay, they want cosecant though. So how do you find cosecant of the angle? Well, it's reciprocal for which one? Cosecant is the reciprocal for sine. So if sine is 21/40, that means cosecant would be 40/21. Hypotenuse over opposite. So you could find any ratio you want though. That's the whole idea, is now we could do anything because we know what the triangle is. Okay, we're going to do one start to finish now to kind of wrap up this piece of it. We're going to find all 6 trig functions for this one. So find the values of all 6 from the perspective of angle R. So this one up here. So we have the side that is adjacent to angle R, the 22. We have the side that is opposite to angle R. The side that we're missing is this one over here. I don't have it yet. I need to find side S, little s, because it's across from angle S. That is the hypotenuse of the triangle, across from that right angle. So we need to do the Pythagorean theorem first to figure out what that third side is. So s squared equals 22 squared plus 14 squared. Give you a minute. Go ahead, pause the video and see if you can go through and find what that value would be and simplify it. So pause the video and find s. So I got s squared equals 680 when you square root and simplify. 4 divides in there, so I think it's 4 times 170. 170 doesn't have any perfect squares, so it would be 2 times the square root of 170. So 2 square root of 170 would be our hypotenuse. So we have all 3 sides. We should be ready to go to find these ratios for angle R. So I'll start with sine of angle R. That's opposite over hypotenuse. So opposite is 14. Hypotenuse, not a great number. Okay, I'm going to reduce first, so divide a 2 out of the whole numbers. So that would be 7 over square root of 170, and then rationalize. So 7 square root of 170 over 170. Next up, cosine. Cosine of angle R. That's adjacent over hypotenuse. So 22 over 2 square root of 170. Can reduce again, and then rationalize. So all of these kind of follow the same pattern. And again, it depends on the angle. If we were doing this for angle T, those would be flip-flopped because the adjacent and opposite would switch. Okay, next one, tangent of angle R. Opposite over adjacent, and that can be reduced. So that would be 7/11. Once you have these, honestly, doing the reciprocals is not that big of a deal. You just have to remember what name goes with which one. So what's the reciprocal of sine called? Well, that one's cosecant. It's abbreviated CSC, so cosecant of R. Now we need to flip. We need to do the reciprocal, but let's be smart about this. There's 3 different things that we have up here for sine. We have number 1 here. We have number 2. Oh my goodness. And then we have number 3. So if you were looking at these 3 ratios, number 1, number 2, number 3, what do you think would be the easiest one of those 3 to flip? Number 2, right? Number 2 is already reduced, but it's not rationalized. If you flip number 3, you're going to have to rationalize it again. If you flip number 1, you're going to have to reduce it again. The one in the middle is the best one to flip. So the square root of 170 over 7 works really well. Okay, what is the reciprocal of cosine called? Well, that's secant, abbreviated SEC. And again, if you had the choice between number 1, number 2, and number 3, I would pick the middle one again. Square root of 170 over 11 is the easiest one to flip. It's already reduced, but you haven't rationalized it yet. All right, and then the last one, the reciprocal of tangent is called cotangent. So cotangent, I would flip the one that's already reduced. So I would flip the 7 over 11, and that would be 11/7. So we can write those trig ratios pretty quickly so as we go through and do that. All right, the last thing that I want to finish up with today, if you can jot these 3 down, I know they're not on your note sheet, I want to show you on your graphing calculator how you can find and type these values in. So if you go to your graphing calculator, you can kind of write them down as we go. Make sure your mode for everything that we're doing is in degrees. So it's the 3rd line down. We'll talk about what radians are a lot more in the next chapter, but make sure you're in degree mode for right now because that's what we use for triangles. All right, so how would you type in some of those smaller units that we did in the last section? So we talked about degrees, minutes, seconds. Just want to make sure you're comfortable and confident typing those in. So sine of 48, remember where you go to get your degrees and minutes in the angle menu, second apps. So 48 degrees and then 12, back to your angle, and number 2. Finish out the parenthesis. You don't have to, but I kind of like to. Just complete things. You don't actually have to, though. And then press enter. So we're going to go ahead and round to 4 places. So 0.74, 0.74555, so 0.7455. One limitation of the calculator when you think about it is you're not going to be able to get probably a nice ratio. It doesn't give it to you as a fraction, it gives you a decimal, primarily because most of these are non-terminating, non-repeating. They're going to be decimals. You're not going to be able to change them over. They're irrational. But we know that that represents the two sides of a triangle. That's what that ratio would divide to if you did it as a decimal. Okay, let's try the tangent one. So tangent. Now we have degrees, minutes, seconds. So 22, go to your angle menu, grab the degrees. 14, go to the angle menu, grab your minutes. And then 10, remember that's not in your angle menu. Where do we find the seconds? Where's the seconds? Alpha and then plus. And then again, I'll finish that off even though I don't have to. And we get 0.4088. Hopefully everybody's able to get that. Now here's actually the trickiest one on here. So I just wanted to check you could do degrees, minutes, seconds. Secant is not a button on your calculator. Secant is nowhere on here, and remember it's not what's right above. So how would you calculate a secant? Well, what is it a reciprocal for? Secant is the same as 1 over cosine of the angle, whatever that angle is. So if you want to calculate a secant, there isn't a button on the calculator, but that's because you can just do 1 divided by cosine of that angle. And you would do the same thing if it were cosecant, I would do 1 divided by sine. If it was cotangent, I would do 1 divided by tangent. Notice if it's just in degrees, not degrees, minutes, seconds, I just typed the 25, I didn't put the degree symbol. That's because the mode of your calculator is already in degrees. So if you don't have degrees, minutes, seconds, you don't have to put the degree symbol. If it's just a whole number of degrees, totally fine. So we'd have 1.1034. And that's rounded to 4 places. So just being able to make sure that you can type in the values that you need. So we talked about the basic trig functions and how to write them in a triangle. So over the course of the chapter, we're going to use that to help us solve real life problems. Trigonometric functions.